regardless of whether we're using pseudocode or flowcharts, we've introduced some pretty important basic concepts here. First is the idea of a variable or a data item with a name like pay, for example, that can have its value changed. We also introduced the idea of decisions, if else, which are called conditional statements, and they allow us to do one thing or another depending on the result of asking a question. For example, is hours bigger than 40? And that's what's known as a control structure, and it allows us to control the flow of the algorithm and therefore the program implementing the algorithm dynamically at runtime, depending on what comes into the algorithm from outside. The important thing to note here is that the types of operation that we're going to use won't be super complicated in themselves. So rather like Lego bricks, each individual operation is pretty simple on their own, but we can piece them together to create incredibly intricate and powerful structures if we have a plan to start off with. So our algorithm was just a list of steps that we had to perform to get from input to output, and that's what a lot of algorithms do. They take in some input, do some processing, and produce an output. And if you think about it, even a game follows this sort of model where the input comes from the controller and the output is the game screen. Very few algorithms have no input or output. So one important aspect of our algorithm was the initialization. We had to set everything up before we started, giving the variables their values, in this case hours and rate. And this is very important as it ensures that the algorithm proceeds from a known state. So here's a summary of what we've covered today. If you want to go into more depth about some of the topics we've covered with an additional example, then you can click on the extra challenge link below. Otherwise, I'll see you next time.